Hello everyone, good evening. Welcome to YouTube session 6, Probability and Statistics. In the previous sessions, we had completed linear algebra, numerical methods, and 2 sessions on probability statistics. This is 3rd session on probability and statistics. In the previous session, we had completed Bayes theorem, rule of total probability, independent events, followed by random variables, 2 types, discrete random variable, continuous random variable. Discrete random variable has the probability function named as probability mass function denoted by P of x. Continuous random variable has the probability function called the probability density function denoted by f of x. Now we are going to start or discuss mathematical expectation, which is also called simply average or mean. We are expecting the value of x or value of any function of x, that is followed by variance, standard deviation, and discrete distributions. Today concept. So the expectation or mean or average of a random variable x, RV means random variables, which I have done short form, is denoted by E of x, that is expected value of x, or some people denoted by mu symbol. The suffix indicate the variable correspondingly, or some people denoted by x bar, and defined as expectation of x is equal to, here onwards every definition 2 types, 2 cases, because of discrete random variable and the other one is continuous random variable. So summation taken over all x values, x times P of x. P of x is the probability of the value x. So product of value and its probability and then summing, that is called summation over x, x into P of x, if x is a discrete random variable. If x is a continuous random variable, I already told you, your operator is integration. Integration taken over all x, x multiplied by its probability f of x, integrating with respect to x. The variance, you know the meaning variance, the deviations in the given observations compared to mean. So the variance of a random variable x is denoted by V of x or var x, var x, or some people denoted by sigma square, and defined as V of x is equal to expected value of x minus mu whole square. Mu is the mean of the x variable, or this is the problematic approach while finding variance, that is E of x square minus mu square. How do you find E of x square? That I will discuss after completing this, where mu is equal to E of x and the standard deviation of a random variable is the square root of variance, that is standard deviation is denoted by sigma. This is square root of E of x. All these are statistical words. Okay. So similarly, I can write similarly, comma, expected value of x to the power any number, that is x square, x cube, etc., is equal to, again 2 cases, discrete and continuous, summation taken over all x values, x to the power r into P of x if x is discrete random variable, otherwise integration taken over all x, x to the power r f of x dx if x is continuous random variable. If you have any doubts, please feel free to ask the doubts. So one more statement questions are sometimes problems also. Expectation of constant C is C. This C is a constant. So both small c, capital C is same. Actually, this is one type of C only. Constant means no change. So when there is no, when you have one observation, there is no change. Mean of that value, that is expected value. Expected of that value is itself only. Variance means change in the observations. If the constant, there is no change, variance is 0. So variance of constant is 0. Expected value of ax plus b, just like differentiation integration, when a constant is multiplying, it comes out, and expectation of constant is itself. But variance of ax plus b, variance of constant 0, this is the only operator. When a constant is multiplying, it will become square after operating v. V stands for variance. Next, expected value of ax plus by is a into e of x plus b into e of y. That is, e is linear operator. But in the case of variance, not like that. The condition is, if the two random variables are independent events, just like independent random variables, okay, then expected value of product of the variables is equal to product of their expectations. That is, e of xy is equal to e of x into e of y. And variance of ax plus by is a square variance of x plus b square into variance of y. A, b, c are constants. So please by heart, we'll do 1 or 2 problems and followed by distributions, discrete distributions. Okay. See, the first question, this is a GATE question. An examination paper has 150 multiple choice questions of 1 mark each, with each question having 4 choices. That is multiple choice questions, 4 choices. One choice is correct, remaining 3 choices are wrong, generally. It's a rare case, 2 options also correct answer. Okay. Each incorrect answer fetches minus 0.25 mark. That is negative mark for wrong answer. So correct answer always 1 mark. Okay. Suppose 1000 students, this is 1 mark each. Negative. 1000 students choose all their answers randomly with uniform probability. The sum total of the expected marks obtained by all these students, 1000 students for 150 questions, we are to finding expected. Okay, that is mean. So solution. So let x, this is a word language problem, x be a RV, random variable. Denote marks per question. So that is discrete. Only 2 type of marks. Okay. Then distribution table. That is how we are distributing the marks for each random variable. That is, random variable is a marks and with probability. Distribution table means x values with probabilities. Capital X is a random variable. Values are denoted by small x. And this is P of x. 1 mark for correct answer. Wrong answer, losing 0.25 marks. That is minus 0.25. So out of 4 choice, 1 choice is correct. So probability of correct answer is 1 by 4. That is probability of 1 mark is 1 by 4. Probability of wrong answer, that is for minus 0.25 marks. There are 3 choices. For correct answer, only 1 choice out of 4 choice. Okay. Remaining 3 choices for false. That is wrong answer. So E of x, that is expected marks per question, is nothing but discrete random variable means summation taken over x values, x times P of x. What is the first x value? 1. Probability of 1 is 1 by 4 plus the next x value minus 0.25. Its probability is 3 by 4. So 0.25 is 1 by 4. So this is 1 by 4 minus 3 by 16. So I can write 4 by 16 minus 3 by 16. 1 by 16 is expected marks per question for one student. Okay. Therefore, expected marks for 150 questions is nothing but 1 by 16 into 150. Hence, the sum total of the expected marks divided by 1000 students for questions is 1 by 60 into 150 into 1000. So we get 9375 marks. Just a minute. So the marks are total marks 9375. The total marks is for 150 questions by 1000 students is 9375. Okay. So the next question, consider a continuous random variable with a probability density function. Discrete random variable related to probability mass function. Continuous random variable related to probability density function. Instead of x variable, it is t variable. So f of t is equal to, it is defined in two subintervals, 1 plus t, for t value lies between -1 to 0, including -1, 0. That is -1 less than or equal to t less than or equal to 0. And it is 1 minus t for 0 less than or equal to t less than or equal to 1. The standard deviation of the random variable is. So we require the standard deviation. Before that, we should find first the mean of the random variable t and the variance of the random variable t. So when it is continuous, it is related to integration. Solution. Expected value of t, that is mean, is equal to integration taken over all t values, t times f of t dt. So it is partitioned into two subintervals, -1 to 0. T times function value is 1 plus t dt plus other subinterval is 0 to 1, t times 1 minus t dt. So this is t plus t square. T integration with respect to t is t square by 2. T square integration with respect to e is t cube by 3. So between the limits -1 to 0 plus this is t minus t square. So its integration is t square by 2 minus t cube by 3. Between the limits 0 to 1. So this is 0 minus lower limit simplifies to 1 by 2 minus 1 by 3 plus this is 1 by 2 minus 1 by 3. Lower limit simplifies to 0. So this simplifies to 0. So mean value 0. Now to find variance, we have to find expected value of t square. So integral taken over all t values, t square times f of t dt. So again, just like as above, I can write -1 to 0 t square times 1 plus t, the first subinterval, plus integral 0 to 1 t square times the second subinterval function is 1 minus t dt. So this is equal to t square plus t cube. Here t square minus t cube. T square integration with respect to t is t cube by 3. T cube integration with respect to t is t power 4 by 4. So this simplifies to t cube by 3 plus t power 4 upon 4 between the limits -1 to 0 plus t cube upon 3 minus t raised to 4 upon 4 between the limits 0 to 1. So this is lower limit, upper limit simplifies to 0 minus lower limit putting t is equal -1. So -1 by 3 plus 1 by 4 plus the second term upper limit 1 putting t 1 by 3 minus 1 by 4 minus putting t is equal to 0 lower limit 0. So 1 by 3 plus 1 by 3 2 by 3 minus 1 by 4 2 by 3, 2 times of 1 by 4 is 1 by 2. So this simplifies to 1 by 6. Therefore v of t, that is variance of the random variable t, is equal to expectation of t square minus expectation of t whole square, that is square of the mean. So this simplifies to mean is 0, 1 by 6. Therefore SD, that is short form of the standard deviation of the random variable RV t is nothing but sigma is equal to root over variance of t is equal to 1 upon root 6. So accordingly, answer is option B. Any doubts? If you have any doubts, please ask. Free to ask the doubts, clear the doubts. Feel free to clear the doubts. Now I am moving to next subtopic, that is discrete probability distribution. Distribution means I told you already, for every x the corresponding probability which is shown by the table in one problem, that is discrete distributions. Okay. So far in the previous sessions or previous problems, they provide p of x or f of x, some t square or 1 by x or t plus 1 or t minus 1, like that just now we done. But now onwards, they won't provide that p of x, f of x. According to the information of the problem, you should recollect or remind that you have to remember by heart. There are some standard distributions having probability. The standard distributions are binomial, Poisson, etc. So they are having ready-made formula, that is p of x or f of x, whatever may be, you have to remember as a formula. Similarly, so far we have learned the procedure for finding mean and variance of a random variables. But the scientists, they have also given for standard probability distributions, mean and variance considered as a formula for time saving. But the only difficulty in this distribution is, according to the question, how to identify That is, this is Bernoulli distribution or binomial distribution or Poisson distribution, etc. By practicing the questions, you will identify immediately the topic name. That is the problem name. Problem name is the name of the distribution. Or else, some applications I'm going to explain after the explanation of each discrete probability distribution. Now let us start. The first one is binomial distribution, short form BD. In an experiment, if the probability that an event happen will not change from one trial to the next. So for example, let us take a coin game. My event is, suppose, probability of getting head. That is my event, suppose getting a head. So if I toss first time, probability of getting head is, for a fair game, unbiased coin or fair coin, probability of getting head is 1/2. Similarly, toss second time, again probability of getting head is 1/2. Toss third time, probability of getting head is again 1/2. So that event is nothing but will not change from trial to trial. Trial means performance of the experiment. Okay. So such trials are called Bernoulli trials. Okay. So a discrete random variable X, Bernoulli trial means only two outcomes. One is called generally success, other is called failure. A discrete random variable X is said to be binomial distribution if its probability is, why it is PMF? Because I told you in the last session, for discrete values, probability is probability mass function, short form PMF. For continuous random variable, its probability is called probability density function, short form PDF. So its probability mass function is P of X is equal to NCX P raised to X into Q raised to N minus X, just like binomial theorem in 11th class, 12th standard or 11th standard. What are the X values? 0, 1, 2, so on here. What is this X, which is a random variable giving the number of times that the event occurs. What is that event depending on the situation? I took an example of getting a head in tossing a coin. If you toss 10 times, what is that means the random variable X number of times getting head. Suppose my experiment is tossing a coin 10 times. That is N value is 10. My event is getting head. So in all the 10 tosses, you may get 10 heads or one toss, one head. That means 9 times head. That is the value of X variable. X is equal to 0, 1, 2, so on N. So here small p is probability that an event will happen and will not change from trial to next. Such trials, again it is repeated here, called probability of success usually. Q is equal to 1 minus p, called the probability of failure. Okay. So this is again repeated sentence, usually called probability of success. N is number of independent trials. Please identify, that means underline independent trials. So this binomial distribution is independent trials only. That means getting head second time is independent on the getting head first time. Similarly, getting head in the 10th toss is independent on the previous tosses or the succeeding tosses. That is called independent trials. So X is number of successes in N trials. N minus X is number of failures. N and P are called parameters of BD. So what is parameter means? If you take coin game, my probability small p is 1/2 getting head or getting tail. If you take dice game, my probability small p is equal to probability of getting 1 or getting 2 dots or getting 6 dots is 1/6. So p changes. N is also some problems 10 times tossed, some other problems 100 times tossed. That is called N is changing. P is also changing from experiment to experiment. Now properties in BD, that is binomial distribution. Mean, we know how to evaluate mean in the previous problems, but not required now onwards. Ready-made formula is available. So in binomial distribution, mean is N into P, variance is N into P into Q. So for a number, if you are multiplying with a fraction, with a proper fraction, the value should be decreases or not. So variance is always less than mean. That means mean greater than variance in BD. So this is the application. Usually BD is applicable in coin problems, dice problem, defective, non-defective objects. Okay. And while practicing more problems in your textbooks or some materials, or gate form material, you will much know and better understand where to apply immediately within seconds. Okay. So please subscribe the channel. GATEFORUM also provides various courses. The first one is live based online classes, usually eGate, and refresher course containing 10 years solutions, all streams. Okay, along with detailed explanation with examples immediately followed by every definition, every note point, there correspondingly an example followed by gate questions, and a test series, 3 types of tests, chapter wise, subject wise, and full length test, that is called target, which is just like main gate exam pattern. Okay, so now when should we apply Poisson distribution? When n is large, usually greater than or equal to 30. If you toss a coin, if you throw a dice 50 times, 100 times, that is called n is large. P is very small. That means suppose P is equal to 0 0.01, 0 0.03, 0 0.05. This is called very small. Then BD means binomial distribution. E is closely approximated by PD. PD means Poisson distribution. That means for a given problem, satisfying n is very large, P is very small. Instead of BD, better apply Poisson distribution. That is, Poisson distribution gives better answer than applying binomial distribution. So after doing one problem, you please cross-check at home the same problem applying binomial distribution, applying Poisson distribution, which is having more chance. Chance means probability. So a discrete random variable x is said to be Poisson distribution PD if its PMF is P of x is equal to e raised to minus lambda multiplied by lambda raised to x upon x factorial. For x values 0, 1, 2, 3, so on. X is large. Lambda value, usually average, is equal to n into p. If mean value is not given in the problem, just taken n into p, product of n and p. So this lambda is finite as well as positive. Is called parameter of PD. In binomial distribution, n and p are parameters, 2 parameters. But in Poisson distribution, only one parameter denoted by lambda. Many times lambda value given, otherwise n into p. Now properties. In PD, in Poisson distribution, mean lambda, variance lambda. So this is the distribution, mean is equal to variance. So this is I already told you. PD is a limiting case of n tends to infinity, p tends to 0. P tends to 0 means p is very small, 0 0.01, etc. N tends to infinity means n is 150, 200, 1000, etc. So these are the applications. Generally, when looking the problem, how to identify whether it is PD or not. Number of printing mistakes per page of a book. So take any book, take randomly any page. Do you think 100 mistakes? Random one mistake or none of the mistakes. That is very less number of mistakes. So such a Poisson distribution example. Next, number of air accidents in some unit of time. So for example, now the time is say 7:40. By this time, how many accidents in a city or in a country? Rare case. One out of 1,000 or 1 out of lakh. One flight is going to smash in thousands of flights at the same time traveling. Okay, that's a rare case. So number of vehicles arriving, passing at a specific highway location. See, this is also a rare case. Number of deaths from a disease such as heart attack, cancer, or due to snake bite. See, randomly you visit a hospital. So do you think all the patients are died or deaths due to heart attack? It's a rare case, 1 or 2 cases, cancer, some other diseases. So these are the live examples. Similarly, by practicing, you will identify some more applications. Okay. Now we'll start the problems. Yes. A lot has 10% defective items. So 10% means out of 100, on an average 10. So 10 by 100 means 0.1. It is not a very small quantity, but a small quantity. 10 items are chosen randomly from this lot. 10 items, that is n is equal to 10. 10 is not a large quantity. So we can't apply by Poisson distribution. The probability that exactly 2 of the chosen items are defective. I told you defective, non-defective is applicable in binomial distribution. When should we apply Poisson distribution? more number of objects, that is n is equal to 30, 40, 100. P is very small, 0.01, 0.05, etc. So, solution, n is equal to 10 items, not large. Let small p is equal to probability of defective item this is 10%, not a small quantity. So 0.1. I can apply binomial distribution. So first find Q, 1 minus P, 0.9. Now the random variable, let X be a random variable, that is RB, denote number of defective items, that is out of 10 items, the number of defective items. So in the 10 items chosen, all the 10 may be defective. Defective means bad, non-defective means good. Or none of the items is defect, that is X value 0. Or only one item is defective, that is X value 1. So this X values 0, 1, 2, so on 10. That is X is BD. That is X follows binomial distribution. So binomial probability is P of X is equal to NCX P raised to X times Q raised to N minus X. Now what is the question? The probability that exactly 2 of the chosen items. Exactly means X value 2. At least 2 means X value greater than or equal to 2. At most 2 means X value less than or equal to 2. These are the 3 verbal language terminologies converted into mathematical language. So therefore, required probability is P of X is equal to 2. This is called exactly 2. Exactly 2 defective. So I hope that everyone following understood, is equal to n value 10, 10 C2, P value 0.1 whole power X, that is square, Q value 0.9 raised to N minus X, that is 8. Please calculate. 10 C2 means 10 into 9 by 1 into 2, that is 45 into 0.01. So similarly calculate. So you will be getting 'I think this is please check. Point 430,467, that is 0.9 raised to 8. So approximately 0.1937. Please check. Accordingly, the answer is option B. So the next example, 1% of the cars manufactured by a company are defective. 1% means 1 by 100 is 0.01, very small. The defective cars by a company. So out of total, but suppose a company manufacture daily 100 cars, only one car is defective. Okay. So on some day, none of the cars is defective. On third day, suppose 5 cars defective. That is on an average, 1% is defective. What is the probability that more than 2 cars are defective if 100 cars are produced? So 100 cars means n is equal to 100. First of all, this is the identification. N is equal to 100 cars. So in that 100 cars, all are defective, or one of the car is defective, or none of the cars is defective. So let small p is equal to probability of defective car. This is also gate question, which is given 1% is equal to 0.01, very small. And this is large. So apply Poisson distribution PD. So average lambda is equal to not given n into p. So that is 1. Now the random variable x be a RV random variable, denote number of defective cars out of 100 cars, all 100 defective. Number of defective cars. So this x values 0, none of the cars defective, or all 100 cars defective. So implies P of x, Poisson probabilities, is equal to e raised to minus lambda times lambda raised to x upon x factorial. Now the question, probability that more than 2 cars, that is greater than 2. Therefore, required probability is P of x greater than 2. That is more than 2 cars defective. Convert into mathematical language. More than 2 cars. So that means maybe 3, maybe 4, or up to 100. Instead of adding all these, 1 minus I can write. In the last class, I told you these things. Okay. Since P of x greater than a number a can be written as 1 minus P of x less than or equal to a. If you take x greater than a success, success opposite is failure. Greater than opposite is less than or equal to. Success plus failure probability is always 1. Similarly, P of x less than a is taken to be success. 1 minus should subtract probability of its failure. Less than a failure means not less than means greater than or equal to a. These are very, very important, which are helpful in many of the problems. So you should subtract from 1 which type of probabilities? Probability of x equal to 0. Similarly, probability of x is equal to 1. Less than or equal to 2 means 0, 1, 2. Minus probability of x is equal to 2. So P of 0, P of 1, probability of 2, in all these respectively obtained in the above P of x by putting by putting x value 0, 1, 2. So in all these, e power minus lambda common, lambda value we got 1. So that is e raised to minus 1 multiplied by, then respectively 0, 1, 2 gives lambda power 0, that is 1 power 0, 1 plus 1 power 1, that is also 1, 1 factorial value 1. Next 1 square 1 divided by 2, 2 factorial value 2. So 1 plus 1 plus 1 by 2, 5 by 2. So 1 minus 5 divided by 2e. This is, please check, approximately 0.08. Please check, everyone. Okay. Now we'll move to practice questions. The fifth problem already done in the previous class. The PDF of a random variable x is as shown below by graphically. The value of alpha is. So it is a continuous random variable. First, from the graph, we have to find the closed form function, that is f of x. So this is a triangle. Excluding this horizontal axis, it is a consists of two straight lines joining. This point is nothing but on x-axis y value 0, x coordinates is distance from origin is a, and this coordinate is x value a plus b, y value this is alpha, and this coordinate is on x-axis again y value 0, a plus c 0. So straight line, st means straight, joining a0 and a plus b comma alpha looks like x1 y1 and x2 y2. Y minus y1 is equal to y2 minus y1, that is alpha minus 0 divided by a plus b minus a into x minus x1. So what is this y? That is f of x. So this is alpha by b into x minus a if x value lies between a less than or equal to x less than or equal to a plus b. This is nothing but y is always connected with x variable by f of x. And straight line joining a plus b comma alpha and a plus c comma 0. Now I want to take this point is x1 y1 and this point is x2 y2. So this is x1 y1 and this point is x2 comma y2. So now I want to take x1 y1 this one, or as you wish, this also x1 y1, this is x2 y2, 2D geometry. So y minus y1 is equal to y2 minus y1, 0 minus alpha divided by x2 minus x1, a plus c minus of a plus b multiplied by x minus x1. So this is. So from this, y is equal to a cancelled, alpha by c minus b can be written as b minus c, because that numerator minus I can adjust with the denominator and writing b minus c multiplied by x minus a minus c. The corresponding x values is a plus b less than or equal to x less than or equal to a plus c. So this y is again f of x. Since f of x is probability density function of random variable x, therefore continuous random variable. When it is continuous, integration taken over x values, this probability f of x dx is equal to 1. So from this, x value is first a2 a plus b, that fx value is alpha by b into x minus a dx plus integral a to b, the next subinterval a plus c, the corresponding y, that is fx value alpha by b minus c into x minus a minus c dx is equal to 1. So alpha by a is constant, x integration with respect to x is x square by 2, constant integration is constant to x between the limits a2 a plus b. Here alpha by b minus c constant, multiplication constant, take out. X integration with respect to x is x square by 2. AC constant, so minus, I can write taking common minus, and then constant integration, constant x between the limits a plus b to a plus c is equal to 1. So this simplifies to alpha by b. It's not alpha by a. So alpha by b into half times upper limit simplifies to a plus b whole square, lower limit that is a square minus this a into upper limit a plus b minus lower limit. Similarly here alpha by b minus c into 1 by 2 into upper limit simplifies to a plus c whole square minus this is a plus b whole square lower limit minus a plus c into, that is I am using curly bracket, into upper limit a plus c minus lower limit a plus b. This simplifies to 1. So finally you will be getting alpha by b here. While expanding, this is a square cancelled, b square plus 2ab. So b square by 2, 2ab means ab. Here a cancelled, minus ab plus alpha by b minus c into half times a plus b whole square, a plus b a square cancelled. So half times c square minus b square minus 2bc, and this is a cancelled, minus of a plus c multiplied by a minus b, a into a square minus ab, and c into c, c square, ac minus ab, c square minus bc. Okay, so after cancelling AC minus AB, next plus C square minus BC is equal to 1. So here simply 1B cancelled, AB cancelled, alpha B by 2, and here C square by 2 minus B square by 2 minus BC, this is cancelled, plus BC. So let me check. This is A plus C into C minus B. So this term simplifies to A plus C into C minus B. A into C, oh, kindly excuse me. This is minus AC. Let me check these three terms. So this is AC minus AB plus C square. So in this BC cancelled. Here C square minus B square. I forgot to write here minus 2AB. This minus 2AB half cancel, minus AB and plus AB. These two also cancel in this bracket. Here two times 2AC, 2AB with my, this is plus I hope that you understand. This is half into 2AC. 1 second, I will write. See, half times a square cancelled. C square, and this is minus 2AC plus 2AC minus 2AB. Okay. And then this is the remaining term. So in this, what are the cancelled? Plus 2AC half minus AC cancelled. And here minus AB plus A minus into minus plus AB cancelled. Okay. So here BC is left. It's not cancelled. So you will be getting plus alpha by B minus C. If I take 2 common into C square minus B square, and this is minus C square plus BC. So minus B square minus C square plus 2BC. So is equal to 1, which implies alpha B by 2 minus alpha by 2 into B minus C into B minus C whole square is equal to 1. So finally, alpha B by 2 minus alpha into B minus C by 2 is equal to 1. If I take alpha by 2 common, B minus B plus C is equal to 1. So alpha is equal to 2 by C. Accordingly, the answer is option A. So it is taking more time because simplification, very tough problem, important. And the next one. 100 identical coins, each with probability P of showing up heads are tossed. So P lies between 0 to 1. It is not a fair game, unbiased to toss, unbiased coin. Maybe P value more, getting head more than getting toss, getting head more than getting tail. Similarly, getting head less than getting tail. Getting head more than getting tail. Similarly, getting head less than getting tail. So probability of heads showing on 50 coins is equal to that of heads showing on 50 coins. So we don't know P value, we are going to find. Given P of X is equal to 50 is equal to P of X is equal to 51. So X is random variable, denote showing heads. Okay. So according to implies this X is coin problems, dice problems, I told you, binomial distribution. Okay. So in this probability of 50 means what is P of X? NCX P raised to X Q raised to N minus X. We don't know P value lies between 0 to 1. I can't apply Poisson distribution. That's why I consider binomial distribution. 50CX, that is X value, I mean 100, N value 100, N value 100 coins, identical coins. So NCX means 100C 50, 100 C 50 into P power 50, P power X into Q power N minus X, that is 50, is equal to P of X is equal to 51 means 100 C 51 into P times 51 into Q times 49. So NCR formula N factorial by R factorial into N minus R factorial. So 100 factorial divided by 50 factorial. I hope that everyone following. into 100 minus 50, 50 factorial. So p power 50, p power 51, p power 50 cancel. Similarly, q power 49 cancel with q power 40. The left side remain with q. And the right side 100 factorial divided by 49 factorial into 51 factorial left with p. Since NCR is equal to n factorial divided by r factorial into. So now this simplifies to 100 factorial cancelled and q can be written as left side 1 minus p. 150 factorial cancelled, 50 remain, and other side 51 factorial cancelled with 50 factorial on the left side will become 51 on in the denominator of the right side. So p by 51, since q is equal to 1 minus p and n factorial can be written as n into n minus 1 factorial. Factorials can be reduced in lowest terms. So cross multiplying 51 minus 51p is equal to 50p. So from this, p is equal to 101p simplifies. So 51 by 101. Accordingly, answer is option C. So I will do fourth problem. On an average, 1 in 100 razor blades manufactured by a firm is defective. Okay, so P is equal to probability of defective blade 1 by 100, which is very small. But N in a packet 5 blades, not large, 30, 40, like that only. So BD is applicable. To apply BD, first find Q. 1 minus P, that is 0.99. X, BA, RV denote number of defective blades in a packet. Implies probability of binomial random variable is NCX, P raised to X, Q raised to N minus X. Okay. So what is required property? What is the property that a packet has at least one defective? So out of 5, at least one means either 1 or 2 or 3 or 4 or 5. So required property is P of X greater than or equal to 1. This is the meaning. At least one defective blade. So I can write this is 1 minus greater than or equal to opposite is not greater than or equal to means less than 1. So X value is already 0 onwards. 1 minus P of X is equal to 0. See in the previous slide, these X values out of 5, none is defective or 1 is defective or 2 is defective, 3 is defective, 4 blades defective, 5 defective. That is the meaning. So that is 1 minus n value 5, 5cx, 5c0, p power 0, 0.01 raised to 0, q power n minus x, that is 0.99 whole power 5. So please simplify. You will be getting 0.049 approximately. Please check. Accordingly, option A is the answer. And one more problem is left. I hope that everyone following understood. Third problem, the range of a random variable, that is x values, 1, 2, 3, that is discrete. This is discrete. Countably finite or countably infinite. And the properties are given by P of x is equal to 3 raised to Cx divided by x factorial. C is a constant. We are going to find that C. So please remember P of x. Since P of x is probability of discrete random variable x, therefore summation taken over x values P of x is equal to 1. That is summation x is equal to 1 to infinity. P of x is 3 raised to Cx divided by x factorial is equal to 1. Am I correct or not? This P of x, 3 power Cx by x factorial. So giving 1 by 1 value for x starting from 1. So 3 raised to C by 1 factorial. 3 raised to 2C can be written as 3 raised to C whole square, because a raised to m whole raised to n is a raised to mn. That is a to the power m whole to the power n is a to the power mn. So 3 to the power 2C can be written as 3 to the power C whole square. 2 factorial. Similarly, 3 power 3C can be written as 3 power C whole cube by 3 factorial plus so on is equal to 1. So just adding in the left side, subtracting 1, adding 1, 1 plus 3 power C by 1 factorial plus 3 power C whole square by 2 factorial plus 3 power C whole cube by 3 factorial plus so on minus 1 is equal to 1. So from Taylor series or Maclaurin series from calculus, one variable e power x or exponential series from 11th 12th standard, e raised to x is 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus so on. So now the left side is e to the power 3 power c minus 1 is equal to 2. So e to the power 3 power c is equal to 3. Right side is 1. I written 2. This is 1 and then this is 2. Kindly excuse me. So this is equal to 1 and finally 2, taking logarithms. So 3 power c is equal to log 2 base c. Again taking logarithms to the base 3, c is equal to log base 3 log 2 base c. If base is not mentioned, that is generally taken to be base c. So this is the logarithms 2 times. One is taking both sides logarithms to the base c. Other is the next step is taking both sides logarithm to the base 3. So this is when the base is not mentioned, automatically the natural logarithm base c logarithm. Otherwise they will mention base 3, base 10, etc. So hope that everyone following. If you have any doubts, please ask. Feel free to ask, clear the doubts. So these are the problems. Please subscribe to the channel and GATEFORUM providing many courses as I already explained. Test series, refresher course, live based internet classes, that is eGate daily. And in the upcoming weeks, we are having some other topics on engineering mathematics followed by technical subjects also. Okay. So with this, I'm closing the session. I'm ending the session. Thank you. Bye-bye.